Okay, so what we're going to do today, you already saw some of the answers up. I'm going to pull them back up in a second. I'm going to first have you just check. There are some of them that I knew yesterday, even before I gave it to you, that I was planning on going over today. They're probably the same ones that you would have questions about. We're going to go over the ones that I want to go over, and then I will answer questions about any of them that you want me to go over. And then I'm also going to pass back the worksheet that you turned in yesterday, that you entered your answers online and turned in, because there's a couple on there I want to make sure we're clear on before tomorrow also. The test is similar to these. Again, the test is easier than the review, in my opinion. And I did split it over 2 days. 19 questions. Actually, sorry. It's 31 points, which means there's 31 answers on it somewhere. This one had a lot more than that. But I think on tomorrow's portion, you have like 1 through 10, 1 through 12. And then on Friday, you'll take the second part of it, which is like 13 through 19, but some of those have multiple parts. Okay, so I just split it over 2 days so you weren't rushing through it. So I'm just going to pull up the answers, and again, I'm just going to give you a minute to check, and then there's some of them that I want to go over. Maybe if my drive's working. And I know one of them, I think number 14, you had to like write sentences in the box. Yeah, number 14's answer isn't up here. It's cut off because it would have been like to the left here where it says answer in box. It would have been to the left. That's one I'm going over. You didn't have to do number 7. I'll try and enlarge this a little bit once it loads. There we go. So for 3A and 3B, I gave them both as fractions. If you gave them as decimals, 1.25, 0.8, that's fine. The only time it matters is if it said give your answer as a fraction or give your answer as a decimal, which those didn't. And that's like on 3C, I gave it both ways. So go through and check. If you need to get up to C, you can. Yes, Bryce. Did you already check all yours? Okay. I'm going to pause this. Okay, so the ones I want to talk about, first I'm going to start on the front page. On number 3. Number 3. It gave one ratio that we knew to be true, and then they asked us 3 questions from that one ratio. For that one, you could have set it up as 3 separate problems, or you could have worked it in one long equivalent ratio problem. Okay, so the information it gave us was that Andre, it takes him 4 minutes to swim 5 laps. A lot of people that were messing these up forgot those words. Are labels important when it comes to ratios? Yes. Okay. So part A said how many laps per minute. What does that mean? Laps per minute. Jack? How many laps in 1 minute? So if I can get that to 1, that box right there will be my answer to 3A. Part B says how many minutes per lap. Cooper, what does that mean? How many minutes per lap? What does that mean? If I'm trying to figure out how many minutes per lap, what am I trying to figure out?
How many minutes per lap?
So how can I set that up in a ratio?
4.5. What are you trying
Stella.
to ask?
You have to get laps to 1.
Yeah, that's how many minutes in one lap. So if I can get that to 1, that answer is my answer to 3B. 3C says if Andre swims 22 laps at the same rate, which means at the same speed, how long does it take him? So then 3C is telling me if I do 22 laps, I want to know my time. Okay, and you could have set up each of those separately, 4/5 to each of those, or even 5/4 as long as your labels matched. From here, I'm just going to look at one set at a time. Sophie, how do I get from 4 to 1?
Times 4.
Times 4? Nope.
Oh, divided by 4.
Divide by 4. So this we could write different ways. We could write 5 divided by 4. We could write 1 1/4. Or we could write it as 1.25. Which one is not an okay final answer? 5/4. The other two would be perfectly okay. So either one of those would be your answer for 3A. How can I get my answer or my labels? What is the label for the bottom row? Bryce?
1.25 laps.
Laps, yeah. Look at the laps. So the box, laps. So 1.25 laps. If I want to be proper, I can say per minute. For 3B, similar idea. I'm going to start with 4 to 5, but I have to get to here. I'm going to loop all the way around all my work there. How do we get from 5 to 1? Divided by 5. Max, what's 4 divided by 5 with no math involved? 4 divided by 5 without doing any math. Yes, you do.
Can't think.
You can. Instead of writing this, how else could I write that? What's another way we can show division?
5/4.
That would be 5 divided by 4. This is 4 divided
4/5.
4/5. So 4/5. And on this one, that's a perfectly okay answer. So really, you didn't have to do any long division. But if I divide that out, 4 divided by 5, if you didn't have that one memorized, which you should, 5 goes into 40 8 times. So our decimal answer would be 0.8. Label would be minutes per lap, or 0.8 minutes, or 4/5 of a minute. For 3C, we can use any of the ratios to build up to 22. Can I easily get 5 to 22? Can I easily get 1 1/4 to 22? Jalen, can I easily get 1 to 22? Yes, by doing what? Times 22. So on top, we could do times 22. So you could have done 4/5 times 22/1, or you could have done 22 times 8 and then counted up one decimal place. Does that make sense? Raise your hand if I just made it easier than you made it yesterday. There were lots of you confused by that one. Okay? That's number 3. The next one I want to talk about was number 5. Now, we haven't done a lot with conversions. That's why I wanted to make sure I left that one on there and I wanted to talk about it. Because even though we haven't done a lot with conversions, we've done a lot with ratios, and that's the easiest way to solve those problems. A conversion is just something that converts a number from one unit to the other. So like 1 foot equals 12 inches. 3 feet equals 1 yard. Those are conversions. But that's giving me something that I know to be true. That's giving me a ratio. So on number 5, it said, which weighs more? A pumpkin that weighs 3.2 kilograms. So the pumpkin equals 3.2 kilograms. Or a cat that weighs 9 pounds. And really we're comparing their weights. Anytime we compare, what do we have to do? We have to make them comparable. Why are they not comparable right now? Sophie?
Because one's kilograms and one is pounds.
Yeah, one's kilograms and 1 pound. So we have options. We can either figure out 32 kilograms is equal to how many pounds, or 9 pounds is equal to how many kilograms. It doesn't matter which way we go. I'm going to set up both of them because I can set up the ratios pretty quickly, and then I think you will decide very quickly which one you would prefer to solve. So we start with the given information, what we know to be true. We know that 1 pound is equal to 0.45 kilograms. Okay, I'm going to set that same thing up over here. 1 over 0.45. Okay, and we know the pumpkin weighs 3.2 kilograms. So I need that number to figure out the pumpkin's weight in pounds. Over here, I know the cat is 9 pounds. So I would have to figure out that number to find the cat's weight in kilograms. Carter, which of those is easier to solve and why? Which one and why? 2 questions. Why? Yeah, so if we look over here, if we were going to solve this one, it's not that it's impossible, but we would have to figure out 0.45 times what equals 3.2. Is that mental math?
No.
No. On this one, if I were going to solve it, 1 times what equals 9? 9. So times 9. So on this one, we would just have to do times 9. So 45 times 9, 5, 4, 36, 40, 1. So I know, right?
It's 4.05. Yeah, there's 2.
Oh, 2 decimal places. Sorry, I didn't write it. 4.05. Now, which is more, 3.2 kilograms or 4.05 kilograms? 4.05. So the cat weighs more because our reasoning would be 4.05 kilograms is bigger than 3.2 kilograms. If you did this one and solved this, would your reasoning be the same? Your reasoning would be different. Would your answer be the same? Yes, you would still say the cat weighs more, but it would be because 9 pounds is greater than whatever pounds you got over on that side. Okay, that one was kind of a weird one. Number 6. Who got number 6 correct? Because I want to see how you solved it, because there's different ways to solve it. Naomi, what did you do?
So the first one is I did 15 minus 9. It says how many hats are not orange.
Okay, so let me put the information up here first. We have 15 hats and 9 are orange. Okay, so you did 15 minus 9 and got 6 that are not orange, right?
Yeah.
Okay, because it asked me for the percent that is not orange. Keep going.
And then I put 6 over 15
Okay, because the part that isn't orange over the whole
equals 40 over 100.
equals box over 100.
Box over 100. And then, so I simplified 6 fifteenths.
Okay,
And 2 fifths.
because you divided by 3, right?
Yeah.
So she divided them both by 3. So 2 fifths equals box over 100.
And then I took 5 times 20 equals 100. And then 2 times 20 equals 40.
40%. Good job. Who got the same answer but worked it different? Chase, what did you do?
I had 9 over 50.
Okay, so hold on. So he started with 9 over 15. 9 is the part that is orange, right? So these are orange. So when he finds a percent, what percent is he finding? The percent that are orange, okay? Keep going, Chase.
I simplified it by dividing by 3.
Okay, so you simplified it to 3 fifths. Okay,
I multiplied them both by 20.
Okay, why did you do 100 minus 60?
Because 9/15s are what is orange?
Okay, because what do the percents have to add up to? 100%. Okay, so if 60 are orange, that means 40 are not orange. Regardless, you would have had to find a percentage and do subtraction somewhere. Does that one make sense? Because there were 2 on the worksheet that was just passed back to you, kind of like that one that I'm going to go over to, because I feel like those are the ones we're struggling with. Okay, do you have any more questions from the front page? Front page. No questions? Okay, second page. The only one I'm going to talk about that I feel like we need to talk about is 11, unless you have other questions. So before we do number 11, I'm going to give you an example of what it's saying. Okay, if I measured Cooper in feet and then I measured him in inches, would he be the same height?
Yes.
Yes. Would I get the same number in feet and in inches? Why?
Because feet are bigger.
Because they're different units, okay? If I use different units, my number answer will be different. Okay? Would his number be higher in inches or in feet? Why would the inches number be bigger? Sadie? Why will there be more of them? Because it's a smaller unit. So if you are measuring the same thing with 2 different units, the smaller unit will use more. Okay? So that's what number 11 was kind of getting you to process. So Claire says that this classroom is 11 meters long. Okay, I have a meter stick right here. So she measured the classroom and it was 11 meters long. So if I measured the length in yards, which if I put my hand over these last 3 inches, 3.5 inches, that's a yard. So is a yard bigger than a meter or smaller? So yard is smaller. I will get less than 11 yards. So if I measure with a smaller unit, will I get a smaller answer? What kind of answer will I get? A larger answer. So Claire is wrong because I will get a number bigger than 11 because yards is a smaller unit. Does that make sense? It was just kind of get you think about different units. Besides that one, are there any from 7 through 12 you want me to work out? 7 through 12? No questions? Speak now or forever hold your peace. Okay. Backside. Number 14. Number 14 is another thinking question. You guys are getting really good at doing math. Okay, what other brain do we sometimes have to use besides our math brain? Our common sense brain, okay? The ones that you had the most questions about yesterday weren't ones that you could just do math and get an answer. They were ones that you had to think about what you know about math and kind of make a inference, there we go, on what it was asking. So number 14 says a baseball team sells snacks at their games to raise money. Are we all familiar with that? Yeah. What do we call that process? Concession stand, okay? So there was a concession stand. At their last game, they made 7/8 as much money as they made at their first game. I'm going to write that out. They made 7/8 as much as first game. And I'm going to put equals last game because that's kind of what it said. So at their last game, they made 7/8 as much as the first game. I think it was Harper came up and said, we can't figure this out because it doesn't tell me how much money they made. I agree. If it gave me any dollar amount for how much they made at either game, we should be able to solve this. But did it ask me how much money they made at either game? No. They just asked, did they make more at the first game or the last game? So this isn't a math question. This is a let's think about it question. There's a couple different ways we could go from here, but Our brains don't work as well with fractions as they do percent, so I'm going to flip it to a percent. Why should we know that one? It's a common one, but I also know as the math teacher for several years that that is a common one, but it's a commonly forgotten one also once you memorize it, okay? So even if you just have a ballpark answer, most people are like 82, 87, 85, somewhere in there. I'm just going to say a wrong percentage, but it's close enough. 84%. It's not exact, but it's close enough that we can still answer. If I said they made 84% as much as the first game,
Then they make less because they're making percent. Yeah, well,
Wasn't that 82.5%?
yeah, 100%.
7. So if they made 100% as much as the last,
They made the same.
then they made the exact same amount. 84% is less than 100%, so they made less money. If it was 120% of the first game, then they made more money. How could we do that without changing it to a percent? How can I do that just by looking at the original problem the way it was given? Nolan.
7/8 is like less than 1/4.
Yeah, this is a proper fraction, which means it's less than 1, which is 100%. What kind of fraction would that have to be for them to make more? An improper fraction would be over 100%. Raise your hand if you overthought that one. Okay. Okay. On that page, I'm going to go over 15 and 17 just because I think a lot of you got there. I think a lot of you just took the long way to get there, so I'm going to refresh your memory on the fastest route. Again, if you got them right, do I care how you got there? No, but I do care about you running out of time. So I'm going to refresh your memory on the quickest way to get there. Number 15a was 5 over 4, 4 over 5, and 12 over 30. Fraction to a decimal. Jude, what are my decimal places? What are the decimal places? If I told you to tell me the place of different digits on a place value chart.
Oh, 1s, 10s, 100s.
So those are on the whole number side. On the decimal side, what are they? What's the first one? Tenths,
100s,
hundredths,
1000s.
thousandths. How can just remembering that help me change fractions to decimals? Harper?
Because if it's a proper fraction, it's going to be less than 1, and if it's an improper fraction, it's going to be more than 1.
That's not wrong, but that doesn't help me. All you have to do is get the denominator to 10, 100, or 1,000. You could divide them out too, but that's the long way. This one, I would go ahead and flip to 1 and 1/4 because most people, when they see 1 and 1/4, 1.25. 1.25. This one, let's just get the denominator to 10. The fraction is 8 over 10. Carter, say that properly.
3 over 10,
Yep, say that properly.
80 tenths.
8 tenths. What does 8 tenths look like as a decimal, Nolan?
0.8.
0.8.
Well, you should already know.
Yeah, and that's also a common one, so it should be in your brain. If you don't remember that, you can take 4 divided by 5, put in your decimal point. 5 goes into 40 8 times. We'd still get the same answer. On the bottom one, can we get the denominator to 10? So divide by 3, divide by 3. Sophia, can you say that properly?
4 tenths.
4 tenths. What does that look like as a decimal?
0.4.
0.4. Okay, it's been a while. We've had to do that when we solve the other problems, but. And 17, percents. How do we change fractions to percents in the easiest way possible? Bryce? No, not change it to a decimal. That's not the easiest way, especially on these ones. Nope. Half right. Reese? Get the denominator to 100 because what does percent mean? Per century, which is 100. So for C, it was already done for us. It was already per 100. That's why the answer was 362. On A, you would have had to multiply them both by 5 to get to 100. So it'd be 60 over 100, which is 60%. And B, you would have had to multiply them both by 10. So 150%. Is that the last page? Okay. Any of them that I didn't go over that you have questions on? Okay, pull out the other paper I gave back. Ooh. There's a couple on here I want to talk about, and then again, I'll answer questions over any of them. You're pulling out this paper. I want to talk about number 6. Okay, number 6 said, last night the 2 dinner specials at Nicholas's favorite restaurant were salmon fillet and steak. The restaurant served 3 salmon fillets and 72 steaks. What percentage of the specials served were salmon fillets? So, you guys have all been to restaurants before, okay? A lot of restaurants have specials, especially like on the weekends. So, at this particular restaurant, when you sit down and when they get your drinks, usually they're like, we have 2 specials tonight. You can get the salmon fillet for blah, 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 blah. It comes with blah, 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 blah. Or you can get the steak special, which is blah, 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 blah. It costs blah, 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 blah. It comes with blah, 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 blah. You guys, does that ring some bells? Okay. So at this restaurant, they're offering 2 different specials. That's all that's saying. Then at the end of the night, they counted how many people actually got the salmon special, how many people actually got the steak special. Which one was more popular? The steak special, okay? 3 people took the salmon special, 72 people took the steak special. It's asking me for a percentage, so we have to find our part, our whole, to be able to do math to find our percent. The question says, what percent chose salmon? So what is our part? Nolan? 3. Okay? It asked what percent chose salmon. So the part that is important is 3. Jude, why is my whole not 72?
Because you have to add them together.
Why?
Because that's like the whole.
Because 72 is also a part. It's not the part I'm focused on, okay? Because part of the people chose salmon, part of the people chose steak. So to find the whole, you have to add those 2 parts together, okay? And again, they had to give us this. Why? Why did they have to give us that in this problem? Jack?
So we knew that we had to add them because we needed the whole.
Because they have to give us at least enough information to find the part and the whole. Okay, and this one they gave us both parts, and we had to think about it to find the whole. So this would be 3 over 75, not 72, equals percent over 100. This can be reduced by 3 to get 1 over 25. Nate, how do we get from 25 to 100? What? Times 4. So 1 times 4 is 4. So 4% of the people that chose specials chose salmon. What percent chose steak?
96.
Why does it have to be 96%? And that would be of the people who chose a special. Do you have to order a special when there is one? No. So 96% of the people who chose a special chose steak. 4% chose salmon. What? Divided by 3/4. Because we divided by 3 and multiplied by 4. That's the same thing as 3/4. Next one I want to talk about is number 8, and it's similar to number 6. But I had some people just miss one and not the other. But number 8 is another one that's similar to number 6. Number 8 says, the students in Maria's grade voted to select a guest speaker. 14 students voted for a famous athlete. The other 26 students in her grade voted for a famous actor. What percentage of the students voted for an athlete? So part, whole, percent. And we are looking for the percent that voted for an athlete. So we need the part that voted for an athlete. Max, what part voted for an athlete? 14. Is 26 the whole amount of people that voted? What does 26 tell me? Jude?
It's your other part.
It's the other part. It's the part that voted for actor. So what is my whole, Ethan? 40. Okay, so that's another one where it gave us all of the people, the different parts, the different votes, but it didn't give me the whole. We would have had to add. From there, I think you guys could have solved. Most people got this wrong, used 26 as the whole. Divide by 2 would be 7/20. Times 5, so 35%. Some people gave me 65%. What did they find?
The thing you took, EX or W was 26.
But what would the labels? It would be the percentage of students who chose actors. Okay, if 35% chose athletes and everybody else voted for actors, then it would have to add up to 100%. Okay, tomorrow what do you have? Test. Okay? Are there any more from either of those pieces of paper you want me to go over? Weekly worksheet is due Friday. Does anybody have any questions over the weekly worksheet? Because this was kind of a hard one because it went lots of old stuff. Yeah, you can turn it in if it's done. Haley. What? So, multiplying mixed numbers. Shh. Haley, what is our rule for multiplying fractions? Guys, everybody sit down. It's not time to go yet. You have to first have 2 fractions. So how do you change a mixed number into a fraction? Okay, so here, I'll just make one up. Okay, multiplying mixed numbers, little refresher. What do we do first, Jude?
You do 6 times 4. Wait.
You're starting over here, you're a little backwards, that's fine. I'm used to it. 6 times 4 plus 1 is what? 25 sixths times, what about the other side? Haley, I'm doing this for you.
Yeah.
Harper, what do I do on the other side?
Same thing.
So specifically.
Yeah, times 5.
So 5 times 6 plus 2 is 32 fifths. From here, you can multiply straight across, but that's not the easiest. That will give you really big numbers. It's not that we're incapable. Chase, what can I do here to make my life easier? So cross reduce. Look diagonally. 5 goes into both of these. So divide by 5. Divide by 5. What about the other way? Could I reduce by anything? 2. Naomi?
Well, you can divide by 2.
So divide by 2. So let me simplify this first. 16 over 1 times 5 over 3. Then we'd multiply straight across. 3, 5. So 80 thirds, we'd have to change it to mixed. So we would get 26 and 2 thirds. Naomi, what was your question? No. Yes. Hold on just a second. Okay. I'm going to give you the rest of the time. If your weekly worksheet is not done, I want you to work on it. You only have 5 minutes, but that's 5 minutes. If your weekly worksheet is done, you can read quietly or sit quietly.